Welcome back everybody, my name is Dustin, and in the last video we added some GLM bindings so we can access functions like vec2, vec3, vec4, and some various other math functions easily from our Lua scripts. And today we're going to actually move onto a simple animation for our sprites. So if we take a look at this picture here, we can kind of get the idea of how it's going to work. For instance, say that we have a sprite sheet that is 128 by 128 pixels. Each frame in this case would be 32 by 32 pixels each. If you remember from before, the UVs of a texture are have the values of 0 to 1. So it would be 0, 0, to 1 to 1. In our case, our textures are flipped, so it's from 0, 0 here, 1 to 1 here. So each frame needs to be a fraction of 1. In order to animate, we're going to want to keep track of the current frame that the animation is in and either scroll vertically this way or horizontally. And if you look at this image here, it would be a horizontal scroll for the animation on these. So you would want to go 0, 1, 2, 3, 0, 1, 2, 3, and so on. It'll keep going back and forth. So we'll want to determine the UV width and the UV height for each frame, and then set the UVs to the current frame number times the width. This one just has start X and start Y. That's basically where do you want to start. So if it's 0, 0, that's just going to be your starting point. And then times your UV width, that will change where your U and your V are. So if, say it's at this one right here, it would be 1, 2, 1, 2, right? So 1, 2, 1, 2 times 0.25 for each. So this would be 0.5, 0.5, and then you'd have your UV width of 0.25 and UV height by 0.25. And it's based on the scrolling direction. So first thing we're going to want to do is actually create the animation component. So let's do that now. All right. So this is the GLM stuff we did last time, but we're going to want to create the animation component. So let's go to our ECS, go to our components, and let's just add it in. New. H file animation component .h. So then we're going to have to include sol, because remember every time now we want to bind all of our components to Lua and EnTT meta, so we need sol for that, and then in our CPP file we'll add in EnTT. So then we go namespace Scion core ECS, and we'll call this struct animation component, or you can just call it animation. And then we're going to need a number of frames. If we go back to that image here, it's not all of this for number of frames, it's number of frames in the animation. So it's 1, 2, 3, 4 in this case. This is just a chunk of the actual drawing. The actual drawing actually has 6 animations, 6 frames for each animation. So we're going to need a number of frames, and that could just be int, and we'll just say num frames, and we'll start that out at 1. And then we're going to also need how fast you want it to go, so that's going to be our frame rate, and we'll start that also out at 1. And then we'll need a frame offset. Now what I need frame offset is, if we look again at this picture, so say we have more over here, or we want to put more images on one sprite sheet, one big sprite sheet, and say you have this guy here, and then right here you start another guy. Well, your frame offset would be right here at number 4. So 0, 1, 2, 3, 4, and then you start the next guy. You'd want to offset these guys so you're not starting at here. So the 0 would actually be 4, if that makes sense, or 5. So let's add that in. So that's frame offset, and it's just going to start at 0. And current frame 0. Cool. We're also going to need to know if it's vertical, so we'll just go bool be vertical, and we'll just say false for now. Okay, that's basically all we need. We'll add more member variables if necessary. So let's go static void create animation Lua bind, and that's sol state reference Lua. Okay, so we've already done Lua bindings before for other components. Why don't you pause the video here and give it a shot yourself and see if you can do it. And if you look, there's no functions here, and these are all just member variables, so this should be a very easy one for you to do. All right, pause it now and give it a shot. Okay, so hopefully you gave it a shot. If not, we're going to do it right now. So let's create this. Cool. All right, it goes Lua, because that's our Lua state, or our sol state going in. and it's new user type, and it's going to be the animation component. Awesome. Cool, that's started, and we're just going to call this one animation. Okay, but up here, I'm going to want to add in EnTT, so let's add that in now. Or entity, EnTT.hpp. And we're going to want to do the type ID. This is so we can have the reflection. And that is EnTT type hash animation component. And that's just the value. And then we want to go to sol call constructor. And we'll do sol factories. And then we're gonna, this will take a num frames, frame rate, the frame offset, and is it vertical? So be vertical, oh sorry, bool be vertical. Awesome. And we're just going to return an animation component. And we'll set our variable, so num frames is equal to num frames, frame rate is equal to, so I call this num frame, let's go num frames. Frame rate is equal to frame rate. Then we go frame offset. Equal to frame offset, and b vertical is equal to b vertical. Awesome. All right, so now we just have to add in the member function. So we'll add in num frames, and that is just an animation component, num frames. Add a couple here, num frames, and then frame rate, frame offset, current frame, and be vertical. I believe that's all of our members. Let's see. Frame rate, current frame, yep, that's all of them. Okay, so this one will be vertical, or you can just call it vertical. And we can call this current frame, frame offset, frame rate. Awesome. Oh, you can name them however you want. For Lua, I like to do them like this, but you can name it however you want it. Cool, that's our animation component. So now that we have our component, remember we have to go into our script system and bind it all. We have to bind it to Meta, and we also have to bind it to Lua. So let's go into our scripting system and add in our animation component here. Okay, we have our animation component. Awesome. And then go down here in our registry, we're gonna have to bind it there. Animation component for our entity, sprite, or not sprite component, animation component. We're also going to need to do a bind. So animation component, create animation Lua bind, and this one only takes in Lua. Okay. So our bindings are good. This should automatically be loaded for us because we're already calling that in the application. So now we actually have to create the animation system. So the animation system, we're going to do that in our systems. So let's close this up and then go to our systems. And in our systems, we're just going to add, and we're going to add a new, and we'll call this the animation system. Animation system.h. Okay. Now let's just check out another system. So I don't remember what our namespace is. It's pretty straightforward. So systems, Scion core systems, or whatever you named your engine. So we have our namespace in, and we're going to need the registry. So that's just ECS and grab the registry. And this is going to be a class, and it's going to be animation system. And our private, we're going to have our registry at the top. So it's Scion core ECS registry, and that's going to be a reference, so we'll just call this M registry. And then we'll have a public animation system, which also takes in a registry reference. And then our destructor can just be default. And we're only going to have the update function. Okay. So let's create those now. And let's go to our animation system.cpp. I want to take this and go namespace Scion core systems. Put that inside. Cool. And then just set up our registry. So M registry. Awesome. Okay, so we're gonna have to add in some of our components. We're gonna want to see the components, animation component. We're gonna want the sprite component and the transform. Cool. And we might as well add in using namespace Scion core ECS. Okay, so we have our namespace and now the update function. So the first thing we're going to do is basically the same. If we go to, say, our render system, we're going to want to get the view from EnTT from our registry and loop through our view. So that's what we're going to do here. So we'll just go auto view is equal to M registry get registry, and that'll be the view. And we want to have the animation component. It needs to have a sprite component. There's no need to animate if there's no sprite, and it also needs to have a transform component. So this is going to filter out the entities to ensure we only get the ones that need to be animated. And then we're just going to say for auto entity in the view. We're going to want to first get the transform. That's just const auto because we're not going to be changing the transform, so it can be const transform is equal to view dot get transform component. That's the entity. Then let's get the sprite component. So auto reference sprite. Oops. Is equal to view dot get sprite component. That also takes in the entity. Then we also want to say auto reference animation is equal to view dot get animation component entity. Cool. All right, so now that we're looping through all the entities that have an animation component and everything that it needs, we need to set the current frame. And the way to set the current frame is we go animation dot current frame is equal to SDL. First we need to add in SDL. So let's go include SDL. SDL dot H. And by the looks of it, we didn't add the SDL library into our core yet, so we need to do that. So let's go up here and go to core and go to our properties. We've done this before, so we need to go to our VC++ directories, go in here, and we'll just put it at the bottom. I'm surprised I haven't added that yet. And then just go to our dependencies, SDL include. Let's get that here. And we can go all of this and just write solution dir. Solution dir, so the solution directory. Copy that because we're going to need to use it again. Okay. And then go to our library. To our library directory, sorry. SDL, lib. Okay. Same thing here. Paste that in. Cool. Then we also have to go to our librarian. Make sure this is on all configurations as well, so we don't have to come back and do this for a different configuration. Unless the configuration actually is different. And then here we want to just go sdl2.lib. Cool. Okay. And we should have SDL. Awesome. So there's our SDL. So then we need to go SDL get ticks times animation frame rate. So we want to multiply it by the speed of our animations and divide it by 1,000. Then we want to take the modulo of the number of frames. This will give us the current frame that we're at based on the time and the speed. Num frames. Cool. So we can just say get the current frame. Okay. So now that we have the current frame, we need to update the UV values. But first we need to know, are we vertical or not? Because how we update the values changes based if we're vertical. So if animation.be vertical, do this, else do this. So if you remember from before, we're trying to set our UV values based on where we are. So based on our current frame, we want to set our UV value. So we need to go sprite.uvs.v. V is basically your Y for UVs is equal to animation dot current frame times sprite dot UVs UV height. Now the UV height should have been determined when you do your generate UVs function. That'll give us the UV height, UV width. And then with this one we can also go sprite dot UVs dot U is equal to animation dot frame offset times sprite dot UVS dot UV width. Now the reason why we have to do this one here is because if we have a frame offset, we need to automatically set it each time because our current frame will set it back to 0, and we don't want to do that if it actually has an offset based on a U offset. Now we could have a V offset, but I'm not worried about that right now. Most people don't set it up that way. This is how I'm going to do it for now. We're not a vertical scroll, which is the one in our animation picture here. So this one here, this is a horizontal scroll. We're going to do it a little bit differently. It's pretty straightforward, but it's a little bit different. Then we just go same idea. In here we go sprite.uvs.u is equal to the current frame animation dot current frame times sprite.uvs.uv width plus the animation frame offset. Animation dot frame offset times sprite dot UVs dot UV width. Cool. All right, that's there, and awesome. We're almost done. So now we want to go to our main application here for the editor because we're starting with the editor. It doesn't look like we're starting with an editor right now, but we are starting with the editor, but we want to get all the systems and everything working first before we start actually building the editor to build a game. So let's get things working first. And we're going to need to add a new system, and that's our animation system. Animation system. And let's go to where we are adding in, or where's our initializing? Render system. Yeah, so we'll just copy the whole render system here. Okay. And we're just going to add in the animation system. So let's change this to animation system. We'll copy this. Fail to create the animation system. add to context, animation system, animation system. Cool, so there we're adding in our animation system there. Yeah, so we're gonna use a different texture as well. I have added the red player texture to my textures. If you want, just go to OpenGL Art and grab any sprite sheet. This is all just for testing. So any sprite sheet and try to do it yourself. But ours is the red player. Red player. And I'll open that right now so you can see what it looks like. And that's just this here. All right, so my goal for today is to get this guy running this way. So that would be 0, 1, 2, and with 6 frames, and we need to add that in. Cool. So we added in our new texture, and let's just call this red player. Cool. So we added in our new texture, and I believe that's all we have to do here. Nope, actually, sorry, I'm wrong. In our update function, we want to just copy this. We're basically going to do the same thing. We're going to want to update our animation. So let's go here and change this to animation system. And it's getting the animation system. And want to update the animation system. Same ideas. Awesome. So now we should be updating our animation system. So let's just build to see if it all works. All right, so it built, that's great. It's not showing anything, so we don't actually have any animating. Well, it looks like it's animation, but that's just being done with the sprite component and the transform component. Okay, so now let's go into Lua and get our guy animating. So let's go to our main.lua, boop, right here. And we already added in this guy last time, this big testy. So let's give a few more components to this guy. Let's give him JADE-ite 2, add component, and we'll give him a sprite component, and that's going to be the red player. And this guy is actually 32 by 32. And we're going to start him at 0, 0. Actually, let's start him down at 2 because I want to. 0, 0 is the blinking. I want him at 2, and the layer can be 0 as well. Okay, and then we're just going to want to go. This one we're going to want to go local sprite 2 is equal to, and then we got to go sprite 2 generate UVs. I think we should do this automatically inside of the sprite component. Like, we need to do this so we don't have to call this, because you may forget and wonder why you don't see your sprite. It's because you never generated the UVs. Okay, so now that we have our sprite, we need to add in our animation component. So EnTT, add component, animation component. And that's going to be the number of frames, which is 6, and we'll give it a frame rate of 10. We'll have no frame offset, and we'll have this as false for vertical. We don't want it to be a vertical animation. And I believe that should be it. JADE-ite 2, number 2, sorry. Let's run it. Awesome, so there we go. We got our guy moving, and he's animating exactly the way we want it to do. Let's try to change our frame rate and see if he goes faster. So if we go frame rate, 15 should move faster. Awesome, he's going faster. That's exactly what I wanted to do. Cool. And let's just change it to vertical to see. So yeah, see, it's going vertically down. Awesome, that's it, that's perfect. So that's basically it for this video. Give that a shot, see what you can come up with. Also, for fun, I recommend that you go into our resources, into our asset manager, and we don't really want to be loading, hard code loading our resources in our application. We don't want to be going here, like, so if we go here and we go back to our application, right? Up here, we're hard code loading the specific textures in. Well, we don't want to do this because, again, we want this to be game agnostic. We want this to have nothing to do with our engine itself. The engine needs to know nothing about the textures that you want to load. So you need to actually add in here, try to make some bindings, some Lua bindings for the asset manager so we can load the textures from the Lua scripts. Okay, we will have a load function that will load the game for you, which will look at a Lua script and load all that stuff for you eventually. That's later down the lines. But we can make these for quick and easy testing. We can make all these functions bound to Lua using Sol. We've done it before. It's the same idea. But if you go to your application, remember our asset manager is a resource for our EnTT context. So we actually have it in the context right here. So we've added it to the context of our registry. So basically we need to use a reference to the registry to get the asset manager to do these functions. So we don't want a constructor. So this will be a Sol, no constructor, and you will use a lambda with a capture reference to get your asset manager. Because there's no need to have more than one asset manager ever, in my opinion. If you think that there is, then go ahead. But then you'll have to decipher which one you're using because they won't have the same content. All right. And then in the next video, we're actually going to start working on our inputs and how we do inputs using SDL. I already did that in my TextRPG video. So if you take a look at those that are TextRPG playlist, we already do something similar. And it's going to be a similar process. We're going to basically do the same idea. But I'm going to change it up for the engine a bit to make it work for us. We're also going to need to do a gamepad and all that, but we're not going to add the gamepad in the next video. The next video is just going to be the keyboard and hopefully mouse control. It depends. I don't want to make the videos too long. All right. Give it a like and subscribe. And if you have any comments, suggestions, or whatever, leave them below and I'll make sure to get back to you with it. All right. See you next time.